Okay, so this is the last bit from this page, I promise. Okay, and it's just the energy for superharmonic motion. So the energy, we kind of looked at this earlier when we looked at potential and elastic energy. So two equations. We've got the potential elastic energy is half kx squared, where k is the spring constant and x is the displacement. And the displacement, the potential energy, because it's a form of energy, it's got a unit of joules. Okay. Similarly, we've got kinetic energy, again a form of energy, and therefore has a unit of joules. And of course, you all know that that's a half mv squared. So you can see the graph here. It's kind of a bit of a strange one. So the green shows the kinetic energy for an oscillator. It goes up to a maximum, comes back down to 0, goes up to a maximum, and back down to 0, and so on and so forth. Okay. At the same time, while that's doing that, if you think about it for a second, when the kinetic energy is 0, that means that the velocity is 0. Okay. When the velocity is 0, that means that the displacement has to be maximum. Okay, it's either positive or negative maximum. So if it's positive or negative maximum, it doesn't make a difference. The potential elastic energy will be maximum. Okay. So this does the exact opposite of what the kinetic energy graph does. Down here at B, the kinetic energy has now got all of the available energy, so there is none left to be in the form of potential, because at that moment the oscillator is now passing the equilibrium point. Could be going either direction, it doesn't really make a difference. And again, it just goes up and goes back down again. So just see if we can make sense of those graphs just a little bit. Please note one thing, okay? And that is that the total energy, so long as there's no friction in the system, and there's no drag, and there's nothing else, it will always stay the same. So what's important about that? Right, if you know either the potential energy elastic, or you can calculate them from the displacement on the spring constant at the maximum position, then you've got the total energy for the spring system. Okay, because the maximum value of the potential energy will be the total energy for the entire thing. Similarly, if you've got, say for example, you've got the mass and you've got a velocity at the maximum velocity, so long as they're at the maximum positions, then that will be also the same. It will be the total energy, because at that stage the potential energy will be 0, and all you have will be kinetic energy. Okay, that makes sense. You need that for these problems of 4.14, where they ask you about the maximum potential energy stored in the spring, and so on and so forth. Okay, so give those ones a shot.